Hello Water Watchers, Gary Burton here. We're going to be doing our stream investigations here at 10 Mile Creek. As you can see, it's a beautiful fall day, blue sky and sunny. A great day for some stream investigations. Our thermometer. Let's take a look and see what our air temperature is today. Looks like we're right at 70 degrees Fahrenheit, which is equivalent to 21 Celsius. So a pretty nice day today for our stream investigations. The first thing we're going to do is we're just going to take some general observations of the creek today. We're going to look and see how clean the water looks, see if we can find any sediment trapped on the bottom, or possibly if the water is not looking very clean and clear. As you can see, the water looks very clear today, and that's typically how our water is in Montana, especially our mountain streams. Now they will get a little dirty in the springtime when we have the snow melt and high water runoff. But right now, in the fall, this water is very, very clear. It does look like we have some sediment on the bottom. I see some pine needles and some fine silt. We'll go underwater and give you a better view. Overall, looks very, very clean. Now right now, the water is quite low. This creek varies quite a bit throughout the year, depending on the time of year, with late summer and early fall being the lowest. You can see we have a lot of exposed gravel and rock because the creek is so low. Now, a couple reasons why this creek is so low. 10 Mile is the city of Helena's water supply. So not only have we not had any rain for the last couple months, one little snowstorm up in the mountains, but the city of Helena is allowed to take up to 8 million gallons a day out of this creek before it ever reaches this point. So two main reasons why the water is so low. The city taking water out of the creek and the weather. Haven't had any rain or snow lately to add water to the creek. Next, we're going to be calculating water velocity. We have some orange and white striped ribbon hanging across the creek as our start line. And roughly 30 feet away, another ribbon hanging for our finish line. We're going to be using a ping pong ball and a stopwatch to figure out how fast the creek is flowing. I've got my stopwatch and ping pong ball, and I'm standing across from our start line. I've got a kick net to retrieve my ping pong ball, and I'm going to have to move pretty quickly to be able to beat the ball downstream to catch it. So we'll start the clock when the ball hits the water. Here it comes. Looks Looks like it got caught in a little eddy there. And stop. Looks like we got 40.19 seconds. Getting ready for run number 2. I think we'll see if we can do 3 altogether. Starting the clock when the ball hits the water. Go. Sometimes you get a fast run, sometimes you get a slow run, sometimes the ball gets stuck. That's why we take multiple runs and calculate an average. And stop. 1 minute 7 seconds, 0.72. Hopefully you guys are writing these down, because I'm going to let you do the math on your own. Time for run number 3. Getting ready for run number 3. Clock starts when the ball hits the water. Go. Stop. That one seemed to be a little bit quicker. As you could see, there's many paths the ball can take, and it looked like it took 3 different paths, all 3 runs. So we should have a good average for our velocity calculation. 28.87 seconds for run number 3. So 40 seconds, 1 minute 7 seconds, and 28 seconds. So for our velocity, you're going to divide your time by 30. And that's going to give you feet per second. It was roughly 30 feet from starting line to finish line for our ping pong ball. And you can divide your average by 30 to calculate the feet per second for the velocity of 10 miles. Now we're taking a look at the stream bed material, and that is, what is the bottom of the creek made up of? Well, as you can see, it's mostly large rocks. Well, let's take a closer look and see if we can find any muck or sediment. So down in between some of these large rocks, we do have some fine, looks like mud and very fine sand, some smaller gravel. We have little rocks about the size of a pea, and then rocks or gravel that's larger than a pea, but definitely smaller than your fist. There's a comparison. We also have rocks larger than a fist, but smaller than a basketball. But taking a look, most of the rocks, a lot of them anyways, are much larger than a basketball. Mostly rock of various sizes making up the stream bed. Now we're going to take a short walk along the stream to see how straight or windy and meandering 10 Mile Creek is. Looking upstream there, it looks like it's flowing around a corner, and as it comes down around the corner, it straightens out for a bit. Moving on downstream, looks like we're going around another corner here. So far, it's a little bit windy, but in between each corner seems to be fairly straight. Looking on downstream, walking, looks like we're approaching another corner. So for the most part, it looks like 10 Mile is not real windy. We have a few small corners here and there, but for the most part, you can see up or down river for a fair ways before the creek disappears around another corner. Now, for the most part, our stream bank seems very stable. We have good vegetation along the creek, some large boulders and rocks holding the creek banks in place. But the vegetation is the most important thing. Without having these riparian trees and plants, the creek banks would be prone to erosion. Those roots and plants and rocks along the stream's edge help to prevent the stream bank from giving away and eroding into the creek. Here we're looking at different components of a creek. What we have here is what is called a run. Part of the creek where the water is fairly swift and somewhat deep. A riffle, on the other hand, is where the water flows over the rocks. It's shallow and swift, and this helps to oxygenate a creek. Those bubbles getting mixed in help to add oxygen to the creek. Usually you find a run right below a riffle, just like here. And then, as the water slows down even more, we have what's called a pool. Over here we have a nice, deep, shady pool. Might be a good place for a trout to hide out. I think I just saw one jump. Now, from the view looking upstream, you can see that the vegetation along the creek is quite thick. In a few places, it's fairly open. But from this view, it looks like it would be quite difficult to walk right along the stream bank due to the thick vegetation. As we said earlier, this is very good. This helps keep the stream banks strong and healthy and limits erosion. But we do see some signs of erosion where I would say the high water mark meets the creek bank. Looking here, it looks like we have places where the water has carved out underneath the bank and amongst the root of a tree. This is right along the high water mark. But you can see that those roots help to hold the creek bank in place. Over on the other side, we have a whole bunch of willow growing along the creek bank. Willows are very good along a creek bank. The root system helps to hold the creek bank in place. Very, very thick willow on that side of it. Well, that does it for our stream investigations. It appears that 10 Mile is a pretty typical Montana stream. Water's quite low right now, which we discussed, but we do have good vegetation in our riparian area, helping to keep the creek bank strong. We also have all the different components of a creek that we were looking for: a riffle, a run, a pool, and a very good mix of stream bed. Our velocity, probably a little slower than normal due to the low water conditions, but overall it appears to be a pretty healthy creek. Next time we'll be doing our water quality tests, which will give us even a better idea of the health of the creek.